Write down. In a rainy day, in the rainy season, good morning, it may rain 70% of the time. If it rains, chance that village fair village fair. Village fair means village mela. Will make a loss on the day is 80%. However, if it does not rain, chance that fair will make a loss on that day is only 10%. If the fair has not made a loss on a given day, in the rainy season, what is the probability that it has not rained on that day? So, in a rainy season, in the rainy day, In a rainy season, one minute, in a rainy day, in a rainy day, in a rainy day, in the rainy season, in a rainy day, in the rainy season, it may rain 70% of the time. It does not rain 30% of the time. Chance means probability. Probability that village fair means village mela. Probability that village mela will make a loss if it is raining is 80%. Suppose it is not raining, probability that village mela will make a loss on that day is only 10%. Suppose the fair has not made a loss, means if the village mela hasn't made any loss, what is the probability that it did not rain on that particular day? This is the information. So here events occurring sequentially, because if it in the rainy season, if it is raining, then only village mela will get some loss. If it is not raining, then only they will also get some loss or profit, something like that. So therefore, events occurring sequentially. Let us draw the diagram. Good morning to everybody. Now, Bayes theorem. Look there. Actually, events occurring sequentially. Sequentially means one after other. Suppose it is raining, village mela will get some loss or will not get some loss. If it is not raining, it will get some loss. It may not get some loss. So, in a rainy season, what will happen? It will rain. This dot is rainy season. Rainy season, it will rain. This is rain. What happens? Rainy season, it will rain and it will not rain as well. Rainy season, it will rain and it will not rain. Look there, rainy season, it will rain 70% of the time. It will rain 70% of the time. And 30% of the time, it does not rain. 70% it rains and 30% doesn't rain. Suppose it is raining, what will happen? Village mela will get some loss. If it is raining, village mela will get some loss. If it is not raining, look there, everyone. In the rainy season, it will rain 70% of the time. So 30% no rain. And moreover, if it is raining, if it rains, chance that village fair will make a loss on that day is 80%. So if it is raining, loss on that particular day is 80%, means 0.80. Now, if it is raining, loss is 80%. If it is raining, no loss, chance is 20%. Now, however, third step, however, if it does not rain, village fair will make a loss on that day is 10%. If it is not raining, village mela will make a loss on that day is only 10%, 0.1. If it is not raining, loss on that day is 10%, no loss will be 90%. Now, last sentence of the problem. If the fair has not made a loss, if the fair has not made a loss on any given day, see, fourth sentence. If the fair, fourth line, if the fair has not made a loss on a given day in the rainy season, what is the probability that it has not rained on that day? So if the village mela did not make any loss on one particular day, what is the probability that it did not rain on that particular day? So first they mentioned already village Mela did not make any loss. So step 1, let us find village Mela did not make any loss. So probability of no loss. So you are here, look here, this is your origin. Destination is no loss. If you want to reach from origin to destination, move along R and then move along L complement. Move along R and then move along L complement. Next, move along R complement and then move along L complement. So to reach L complement, first move along R. Answer 27 by 41 is correct. 0.65 is the right answer. So first move along R and then move along L complement. R means plus, move along R complement and then move along L complement, that is 0.9. So this is 0.14 plus 0.27, that is equal to 0.41. Why I found P of L complement? They mentioned already, if the fair has not made any loss, what is the probability that it has not rained? Means if the village Mela did not make any loss, what is the probability that it did not rain? So that's why I found village Mela did not make any loss as a first step. Second step is what they mentioned, if the village Mela did not make any loss, means L complement, what is the probability that it did not rain? It hasn't rained. It hasn't rained means R complement. This is P of A given B. This is A, this is B. Bayes theorem, one kind of conditional probability only. This is A, this is B. P of A given B formula, P of A intersection B by P of B. So numerator is R complement and then L complement. Numerator is R complement. R complement probability 0.3. After that L complement probability. R complement and L complement means first R complement 0.3 and then L complement 0.9. Denominator probability of L complement is 0.41. 0.41. So this is a 0.27 by 0.41, that is 27 by 41, that is a 0.65. Next. But they asked only rainy season. Only no. Then we need to consider R complement also. Could you clarify again when to use conditional probability and when to use Bayes theorem? Conditional probability means two events will be given. One event already known. By using that already known event, if you are asked to find unknown new event, then use conditional probability. Bayes theorem almost same only, but before Bayes theorem also one type of conditional probability only. But first of all, read the problem, events occurring sequentially. After sequential of events, you are asked to find inverse. Sequence means, look here, if it is raining, village Mela getting loss. If it is raining, village Mela no loss. If it is not raining, loss. If it is not raining, no loss. Now, sequence of events. And at the same time, you will be asked to find converse of the statement. converse of the statement means, look here, if converse of the statement means what? If the Mela has not made any loss, what is the probability that it has not rained? Actually, if it is not raining, then no loss will be 0.9. Converse means what? If there is no loss, what is the probability that there is no rain? If there is no loss, what is the probability that there is a rain? If there is a loss, what is the probability that there is a rain? That is converse. So, sequence of events and you are asked to find the converse of the given statement, reverse. Actually, after no rain, then only no loss will occur. Suppose you are asked to find if there is no loss, what is the probability that there is no rain? That is converse. Then we can use. Write down. One more. Problem number 3. The chances that Dr. A diagnoses a disease capital X correctly is 60%. The chances that a patient will die by his treatment after correct diagnosis is 40%. And the chances of death by wrong diagnosis is 70%. What is the conditional probability? Means as per the context. Look here, last sentence, if the fair hasn't made any loss. If the fair, already known event here, unknown event here. If the fair did not make any loss, what is the probability that it did not rain? Unknown event, known event. They only clearly mentioned. If the fair did not make any loss, then chance that it did not rain. What is the probability that a patient died with disease X. Next, if a patient died with disease X, what is the probability that his disease was diagnosed correctly? Chances means probability. Remember, the chance that Dr. A diagnosing a disease capital X correctly is 60%. Probability of Dr. A diagnosing a disease wrongly should be 40%. So the probability that patient will die by his treatment after correct diagnosis. After correct diagnosis means first correct diagnosis was given. After given the correct diagnosis, probability of patient will die is 40%. Probability of a patient will die after giving wrong diagnosis is 70%. Look here everyone, events occurring sequentially. First sequence is doctor has given correct treatment. After correct treatment, chance of death of the patient is 40%. Another stage is doctor has given wrong treatment. After wrong treatment was given, chance of death of the patient is 70%. Answer 0.5 to 0.46 are okay, fine. Look here, first what's happening? First correct diagnosis was given. After correct diagnosis, that should be 40%. Next, wrong diagnosis was given. After wrong diagnosis, death is 70%. Look there. First correct diagnosis, I will write in the next slide. There is no sufficient space here. Going to the next slide. So first correct diagnosis was given. Correct diagnosis was given. Next, if correct diagnosis will be there, then obviously wrong diagnosis will also be there. Then wrong diagnosis 0.5 to correct. So now after correct diagnosis, death is there. After correct diagnosis, the chance of patient death. Next, no death. After wrong diagnosis, death will be there. After wrong diagnosis, no death will be there. First correct diagnosis probability 60%. Diagnosing a disease correctly 60%. 60% means 0.6. If correct diagnosis is 60%, wrong diagnosis is 40% because sum of the probability is 1. 0.46 is correct. 0.46. Fine. 6 by 13. Second problem answer 0.46. 6 by 13 is correct. See, after correct diagnosis, death is 40%. After correct diagnosis, death is 40%. Means 0.4. Then no death will be 0.6. Next, after fourth step, after wrong diagnosis, death is 70%. After wrong treatment, death is 70%. Then no death will be 30%. No death will be 30%. Problem number 1. What is the probability that a patient died with disease X? Probability of a patient died with disease X. So, problem number 1, probability of death. To reach death, move along correct diagnosis and then along death, or move along wrong diagnosis and then along death. So, first to move along correct diagnosis, 0.6, and then death, or move along wrong diagnosis and then move along death. So what is this value? 0.24, 0.28, 0.52. Second question is, according to the conditional probability, already known event is here, unknown event is here. If the patient died, converse of the statement, look here, converse of the statement, Bayes theorem. Converse means what? If a patient died with the disease X, what is the probability that correct treatment was given? Generally, after correct treatment, patient died. Converse means if patient died, what is the probability that correct treatment was given? That is converse. So, patient died. Already known event is death. Known event is death. Then what is the probability that correct diagnosis? That is equal to probability of correct diagnosis and death by probability of death. So numerator correct diagnosis and death. Numerator first correct diagnosis. Correct diagnosis is 0.6. After that, death 0.4. Denominator 0.52. This is 0.24 by 0.52. Simplify, it may be 6 by 13 or as you said 0.65. Note this problem and try yourself. A 2020 gate, one problem was given. Earlier computer science also this model was covered. Note this and try yourself. Next. Yes, correct. Note down. Note this and try yourself. Consider two identical bags B1 and B2, each containing each containing 10 balls of identical shapes and sizes bag B1 contains 7 red and 3 green balls. While bag B2 contains 3 red and 7 green balls. A bag is picked at random and a ball is drawn from it which was found to be red. The probability that the red ball came from bag B1 round off to 1 decimal place is dash. Round off to 1 decimal place is dash. It was given 2020 gate instrumentation engineering. Answer very good. Answer 0.7. Next slide. Try later. Random variables. Definition: random variable. So what do you mean by random variable? Please solve. I should not solve all questions. Some questions you must practice yourself so that your skills will also be improved. So random variable means random variable assigns real numbers to outcomes of the random experiment. 0.7 is the answer. Random variable assigning. Random variable is a variable, that is one variable that assigns real numbers to outcomes of the random experiment. For example, look here. First you write the definition. Otherwise, look here, if two coins are tossed, what are the possible outcomes? Head head, head tail, tail head, tail tail. This is what? Sample space. Set of all possible outcomes of the random experiment is called sample space. This is x-axis. On x-axis we have minus infinity to plus infinity. Now I want to define something. That is, I want to define x is equal to number of heads. I want to define x is equal to number of heads. So here head head contains two heads, head tail containing one head, tail head also containing one head, tail tail containing 0 heads. If I assume x is equal to number of heads, HH contains two heads, HT, containing one head, TT containing 0 heads. So here x is a random variable, random variable. So random variable is a variable that assigns outcomes of the random experiment. That assigns outcomes of the random experiment are HH, HT, TH, TT. That assigns real numbers to outcomes of the random experiment. HH, HT, TH, TT. That is called random variable. It is also defined like this. Random, look here, this example. This is the sample space. This is the real numbers. This is HH, HT, TH, TT. This is a domain. This is a domain. This is range. So here 0, 1, 2. X means what? Number of heads. HH containing 2 heads, HT containing 1 head, TH containing 1 head, TT containing 0 heads. So therefore random variable is a function, means capital X is a function whose domain, this is the domain. Domain is the sample space. Domain is the sample spaces and range. This is range. Range is set of real numbers. Range is set of real numbers. Random variable is one variable. That variable belongs to a function category whose domain is the sample space and range is set of real numbers, minus infinity to plus infinity. Definition. Right now. random variable, briefly written as RV. Random variable is a function. Only integers are possible. Yes, random variable will take only integers. On random, see, real numbers will also have integers, no? Real numbers will also have integers. Random variable is a function whose domain is the sample space and range is integers. Real numbers will also have integers. Range is, because we don't have any integers line, we have only x-axis. On x-axis we have everything, integers, real numbers, fractions and everything. In order to represent on the diagrammatic format, I am choosing real numbers. Actually it is integer only. And range is set of real numbers. Next slide. It is also written like this. A random variable assigns outcomes of the assigns we don't have, Ojasvi Jain, we don't have any real numbers under any circumstances. It is always an integer only. How the negative values are possible? So negative values means, for example, you may choose chemical reactions also. See here, listen to me, it is not mandatory that it must have negative values. It may have, suppose, tossing of a coin experiment, outcomes 1 head, 2 heads, 3 heads. In that case, positive integers possible. Suppose the chemical reaction is possible. Suppose in a chemistry subject, X represents number of readings or the measurements in any chemical experiment. Sometimes it may give negative values also, -2, -3, something like that. So that's why negative values also possible. But 90% most of the practical situations positive integer only. But some chemical reaction problems also X may take negative values. The readings may be negative. Random variable assigns real numbers to outcomes of the random experiment. Example, suppose two coins are tossed the sample space is equal to S is equal to head 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 tail, tail head, tail tail. You may assume x is equal to number of heads or number of tails. That's up to you. You can assume in any manner. Definition range should always be set of integers only. But I want to represent in the diagrammatic format Ojasvi Jain. In that diagrammatic format, I will choose x-axis and y-axis. So do you have any integers separate line? No, x-axis is a real axis, y-axis is a imaginary axis. Just to represent, I am choosing x-axis, means set of real numbers. That's it. It is always integer, integer, integer. Let x is equal to number of heads. Next slide. This is the sample space. It has HH, HT, TH, TT. This is set of real numbers 0, 1, 2. There is a relationship between sample space and real numbers. So here HH contains 2 heads, HT contains 1 head, TH also containing 1 head, TT containing 0 heads. Probability doesn't contain negative values. Probability of random variable can be negative, but probability always positive. Probability always positive. Random variable may be negative or positive. There are two types of random variables. First one is discrete random variable. Next one is continuous random variable. Next slide. Definition. Discrete random variable. So what do you mean by discrete random variable? Discrete random variable means a random variable that takes finite number of values. Finite number of values or countably infinite number of values. Discrete values means separate x values like 1, 2, 3, 0, 4, 5, so on. So random variable taking discrete values, I mean finite number of values or countably infinite number of values, that is called discrete random variable. You know, I mean number of students in the classroom, number of benches in the classroom. These are discrete random variables because a random variable taking finite values like 1, 2, 3, 4, so on, or countably infinite values. Countably infinite values means like 1, 2, 3, 4, 5, 6, 7 up to infinity. A random variable which takes finite values or countably infinite values is called a discrete random variable. Example means any example. Number of students in the classroom, number of pens, number of equipments, number of mobile phones. Next definition. Countably infinite values. Countably infinite values. Countably infinite values means which we are able to count like 1, 2, 3, 4, 5, 6, 7, 8 up to infinity. These are called countably infinite values. Number of stars in the sky are countably infinite values, like 1 star in the sky, 2 stars in the sky, 3 stars in the sky, infinite number of stars in the sky, which are called countably infinite values. Uncountable values means a random variable that takes uncountable values, or a random variable that takes all values of an interval, that is called continuous random variable. For example, uncountable values means number of vehicles crossing the junction from morning 9 o'clock to 10 o'clock. Actually, finite number of vehicles can cross the junction from morning 9 o'clock to 10 o'clock, that is fine. But exactly how many vehicles crossing the junction from morning 9 o'clock to 10 o'clock at any particular day can you say? If you go and sit there by counting only you can say, but you cannot estimate these many number of vehicles definitely crossing the junction exactly 1 hour from morning 9 o'clock to 10 o'clock. So a random variable that takes uncountable values are all values of one interval, that is called continuous random variable. For example, number of vehicles crossing the junction from morning 9 o'clock to 10 o'clock. If you go and sit there and count exactly finite, but daily how many vehicles crossing from morning 9 o'clock to 10 o'clock you cannot say. And moreover, the amount of rainfall, will you guess the amount of rainfall, like one rainfall, two rainfalls, three rainfalls, four rainfalls? No. So uncountable values any variable can take, that's continuous. A random variable which it takes all values of an interval are uncountable values is called continuous random variable. Probability mass function probability mass function is simply called probability function is also called point probability function. So what do you mean by probability mass function? Very simple. Probability value corresponding to discrete random variable is called probability mass function. The probability function corresponding to discrete random variable. The probability function corresponding to discrete random variable short form RV, corresponding to discrete random variable is called probability mass function. Probability mass function, comma, provided it satisfies the following conditions, comma, provided probability value corresponding to discrete random variable is called probability mass function, provided it satisfies the following conditions. Probability value is always greater than or equal to 0 for all x. And moreover, sum of the probabilities is always 1. So probability function corresponding to discrete random variable satisfying these two conditions is called probability mass function. For example, a random variable capital X taking the values 0, 1, 2, 3. Here P of X 0.1, 0.3, 0.2, 0.4. So a random variable that takes discrete values. Discrete values means separate x values like 1, 2, 3, 4 or finite number of values. That random variable is called discrete random variable. Discrete random variable. So probability function, this is the probability function corresponding to discrete random variable. Therefore, it is called probability mass function. Remember, probability function corresponding to continuous random variable is called probability density function. Range of discrete random variable is any x value from minus infinity to plus infinity. Probability mass function means probability value P, probability value corresponding to discrete random variable. This here discrete random variable means a random variable taking finite values. So probability value corresponding to discrete random variable is called probability mass function. For example, a coin is tossed 3 times. X means what? 0. So for example, a coin is tossed 3 times. X is equal to number of heads. So 0 means X is equal to 0, 0 heads. X is equal to 1, 1 head. X is equal to 2, 2 heads, 3 heads. P of X is equal to 0 means probability of X is equal to 0 means probability of 0 heads, probability of 1 head, probability of 2 heads, probability of 3 heads. This probability corresponding to discrete data is called probability mass function. Write down probability density function means the probability function corresponding to continuous random variable is called probability density function. It should not exceed 1. P of x greater than or equal to 0 means 0 less than or equal to P of x less than or equal to 1 only. P of x here, P of x greater than or equal to 0 means 0 less than or equal to P of x less than or equal to 1. Provided the following conditions are satisfied. Condition number 1, f of x greater than or equal to 0 for all x. Condition number 2, remember discrete random variable sigma p of x is equal to 1. Means sum of the probabilities is equal to 1 for a discrete random variable means sigma p of x is equal to 1. For continuous random variable, sum of the probabilities is equal to 1 means integral minus infinity to plus infinity f of x dx is equal to 1. Means sum of the probabilities is equal to 1 for continuous random variable, meaning it is moreover integral minus infinity to plus infinity meant for area under the curve between minus infinity and plus infinity is always 1. Next definition. Mean. Also called average or expected value of a random variable. Mean of a random variable, average value of a random variable, expected value of a random variable will have same meaning. Mean of a random variable is denoted by E of x, also denoted by lambda, also denoted by mu, also denoted by x bar. Mean of a random variable is denoted by any one of these notations and is defined as sigma x into p of x. Here the random variable x is discrete. X is a discrete random variable. If x is continuous random variable, mean formula integral minus infinity to plus infinity x f of x dx. X is continuous random variable. Probability density function means example of probability density function. Probability density function means probability value corresponding to any continuous random variable. Probability value corresponding to any continuous random variable. Any continuous means continuous random variable means, for example, probability of x is the, you define x is equal to the number of vehicles crossing the junction. X is equal to number of vehicles crossing the junction from morning 9 o'clock to 10 o'clock. That is continuous random variable. F of x means probability for continuous random variable throughout probability and statistics. F of x means probability of a vehicle crossing the junction from morning 9 o'clock to 10 o'clock should be defined in terms of x. That is f of x. Next definition. Variance mean of a random variable means average value of random variable. So what is the variance of random variable? What do you mean by variance? Listen to me. Suppose maths exam has been conducted to all students of this classroom. Listen to me. Suppose maths exam has been conducted to all students of this classroom and you identify class average mark. Suppose this is class average mark. This is class average marks. Most of the students will have very near to class average marks. So class average marks. How this is class average marks. Most of the students will be nearer to class average marks. How this is one particular student marks. How each student marks varying with respect to class average marks. How each student marks varying with respect to class average marks. That is the measure of calculation of each and every student marks varying with respect to class average marks. That is called variance of marks of the students in one particular subject. Variance of marks of the students in one particular subject. So variance means the measure of the dispersion. The measure of the dispersion. Dispersion means deviation or scatter. Scatter or dispersion means deviation of the values of the random variable. Values of the random variable means marks of the students. Values of the random variable means x is equal to 20, 30, 70 like that. Which are the marks of the students? Values of the random variable means marks of the students about the mean mu. About the mean mu. Values of the random variable means marks of the students. About mean mu means about class average marks. About class average marks is called variance of random variable. Suppose if the values tend to be concentrated near the mean, the variance is small. So what I said, if the values tend to be concentrated nearer the mean, look there, if each and every student marks very nearer to class average marks, this is class average marks, every student marks, here one student, here one student, each and every student marks very nearer to class average marks, then variance is small. If values means marks of the students, if the values tend to be distributed far from the mean, comma, the variance is large. Values distributed far from the mean. Values distributed far from the mean. So this is mean marks. Now here one student marks. The difference between each and every student marks and class average marks is far, then the variance is large. The difference between one particular student marks and class average marks is very small. The variance is small. Listen to me. Regarding let me draw it correctly. So here in case of small variance, listen to me, in case of small variance, the curve is very nearer to the mean mu. In case of large variance, the curve is deviated far from the mean. In case of small variance, curve will be concentrated very nearer to the mean. In case of variance, curve is deviated, the curve is deviated far from the mean. See, variance means not only difference. Variance is a measure of not difference between random variable and mean value. Not only that, variance is the average value. Look here, variance is the average value of one particular student marks minus class average marks whole square plus second student marks minus class average marks whole square plus on last student marks minus class average marks whole square divided by total number of students. This is variance. Because if you take the difference, one particular student marks minus class average marks, then you will get negative also. So variation between one student marks and other student marks is always positive. You got 20, other student got 15. So or 50, the difference should be 30 marks, not minus 30 marks. In order to avoid that negative, we need to take whole square. Average, not error. Okay, up to some extent that is correct only. Average value of error is called variance. Instead of that, better to say average value of squares of the differences between values of the random variable and mean of the random variable is called variance. Mathematically, it is written like this. Mathematically, it can be expressed as like this, variance of x. If you want, simply write v of x, also written as sigma square x, and is defined as E of. E means, remember, E means expected. Expected means average. E means expected. Expected means average. Variance of x or V of x or sigma square x E of x minus mu whole square is equal to here x is discrete random variable. Here x is continuous random variable. Note, x bar means average value. Statistically, mean is also written as x bar. Statistically, average value. Write down. So here, variance of x is equal to sigma square x Note first one, e of x minus mu whole square. After simplifying this, you will get e of x square minus e of x whole square. After simplifying this, you'll get like that. After simplifying this, we will get like this, e of x square minus e of x whole square. E of x means mu only. And we all know that variance is denoted by sigma square. Something whole square is always greater than or equal to 0. Something whole square is always greater than or equal to 0. That something whole square value e of x square minus e of x square minus e of x whole square greater than or equal to 0. So this is e of x square greater than or equal to Computer Science Engineering 2010 and Electronics Engineering 2014. One more question was given and it was asked like this: which of the following statement is true? Which of the following statement is true? Option A, e of x square greater than or equal to e of x whole square. Option B, e of x square greater than e of x whole square. Option A, greater than e of x square greater than or equal to e of x whole square. Option B, only greater than. Option C, less than. Option D, less than or equal to. Therefore, this is the right answer. So everyone should remember that expected means average. Average value of square of the random variable. Expected means average. Average value of or expected value of square of random variable is greater than or equal to square of average value of the random variable. Remember, average value of sum of the squares, average value of sum of the squares is always greater than or equal to square of average values. Average value of squares of the variables is always greater than square of average value of the variables. For example, look there, x value 1, 2, x square value 1 square, 2 square, e of x. E of x means what? Average value. E of x means average value 1.5. E of x whole square is 1.5 whole square 2.25. E of x square is 1 square plus 2 square by 2. So E of x square is 2.5. 5 by 2, 2.5. Therefore, E of x square always greater than or equal to E of x whole square. E of x means average only. So average value of square of one variable always greater than or is equal to square of average value of the variable. Square of average value of the variable. 3 by 3. What is 3 by 3? Next. Next. Write down the definition standard deviation. Standard deviation means positive square root of variance plus into root of variance is called standard deviation. Write down. The positive square root of variance is called standard deviation. So standard deviation is denoted by plus root of variance is called standard deviation. Plus root of variance means square root of sigma square. Square root of sigma square is a sigma. That is standard deviation. Definition. No particular application of standard deviation. Covariance, that plus root of variance is the actually standard deviation is right. Variance is the part of standard deviation. Look there, covariance. Variance means what? Actually, the purpose of variance is we are measuring how each student marks changing with respect to class average marks in one particular subject. Covariance means how each student marks changing in two different subjects about their class averages in those two different subjects is called its covariance. Covariance means what? The measure of dispersion, the measure of dispersion of the values of two random variables x and y. Values of two random variables means values of marks of the students in two different subjects. First subject marks x, second subject marks y. About their means. About their means mu suffix x, that is the average value of first student marks, mu suffix y, average marks of second subject, is called so mathematically. Variance and covariance 100% similar. Variance means variation of marks of the students in one particular subject about their class averages in that particular subject. Covariance means variation of marks of the students in two different subjects about their class averages in those two different subjects is called its covariance. Now, mathematically, it is written like this. Note. If capital X and capital Y are independent random variables, then E of xy is equal to E of x into E of y. Actually, if x and y are independent random variables, E of xy will be E of x into E of y. Definition. That is independent random variables. In covariance also all students only. How each student marks. There are several students in covariance also. How each and every student marks changing in two different subjects about their class averages in those two different subjects is called its covariance. Variance means how each student marks changing in one particular subject about their class averages in that one particular subject. If x and y are independent random variables, then its covariance is 0. Yes, variance means one quantity, covariance means with respect to two quantities. Write down. Covariance of xy is equal to E of xy, sorry, minus E of x into E of y. They have already mentioned x and y are independent random variables. Then E of xy value, E of x into E of y minus E of x into E of y 0. So if x and y are independent random variables, its covariance will be 0. Heading. Next slide. Real example only I said. Second point. Okay. Actually, the second point, if x and y are independent random variables, actually covariance 0 means independent random variables. If there is no any, actually mathematically, if there is no any relationship, see, you only tell me practical example means if x and y, I am one person and you are second person. There is no relation between two people. If there is no relationship between x and y are individual persons, there are nowhere concerned. There is no any relationship between them. Then covariance means what? Is there any variation between them? Covariance is always 0. Variance means variation between two objects. Variation or a difference between one object and average of another object. Heading. Properties of mean and variance. Write down the properties. How covariance will be 0? If there is a formula, actually this is not formula. E of xy is equal to E of x into E of y. X and y are independent random variables. Actually, independent random variables definition is different. That should be defined with respect to probability density function. F of xy is equal to f of x into f of y. Then x and y are independent random variables. From that we are writing E of xy. E of xy not a definition. Write down the properties. Average value of k is equal to k. Next, average value of ax, a into average value of x. Average value or expected value of ax plus b. That is a into average value of x plus b or minus b. Variance of k 0. Variance of ax is a square into variance of x. Variance of ax plus by or variance of ax plus or minus b is equal to a square into variance of x next slide. If x and y are independent otherwise variance of ax plus by or ax minus by this is a square into every result is a theorem statement that we can prove. Yes, same. Sixth and seventh are answers same. If x and y are independent random variables, then variance of ax plus or minus by is equal to a square into variance of x plus b square into variance of y. Because x and y are independent random variables, then its covariance will be 0. Then its covariance will be 0. Problems? That's why this third step has been 0. Write down heading problems. Break will be given. Write down problem number 1. Simple question. The two sides of The two sides of a fair coin are labeled as 0 and 1. The coin is tossed two times. Independently. Let capital M and N denote the labels corresponding to the outcomes of those tosses. For a random variable capital X defined as X is equal to minimum of M comma N the expected value E of X round off to two decimal places is a dash. It was given GATE Electronics Engineering 2020. Actually, two sides of a coin, generally head and tail. In this problem, we were asked to assume two sides of the coin as 0 and 1. One side of the coin 0, other side of the coin let it be 1. We were asked to assume. That type of coin was thrown two times. Capital M and N represents the outcomes of the tosses. Outcomes of the tosses are 0 and 1. And we were asked to assume X is equal to minimum of M comma N. Look here, M and N are outcomes of the tosses. So therefore, this is M, this is N. Suppose two coins are tossed. Outcomes are 0 and 1 only, because on the coins printed numbers 0 and 1. So two coins are tossed. First coin showing 0, second coin showing 0. First coin showing 0, second coin showing 1. First coin showing 1, second coin showing 0. First coin showing 1, second coin showing 1. So one side of the coin printed 0 number, other side of the coin printed 1 number. If that type of coins, two coins are tossed, First coin showing 0, second showing 0. First 0, second 1. First 1, second 0. First 1, second 1. These are the possible outcomes. So now what is x? You are asked to assume x is equal to minimum of m comma n. Tell me x is equal to minimum of m comma n means minimum of 0 comma 0, minimum of 0 comma 1, minimum of 1 comma 0, minimum of 1 comma 1. Therefore, minimum of m and n are 0 and 1 only. Minimum of m and n are 0 and 1 only. So, probability distribution table here, x values 0, 1. X values 0 comma 1. So here probability of x. Now x value 0. X value 0, total 4 cases 0, 0, 0, 1, 1, 0, 1, 1. So x value 0, how many cases favorable? Tell me. Probability of x is equal to 0. X is equal to 0. Minimum of 0 comma 1. Minimum of 0 comma 1 is x value 0. Someone has solved. Answer 0.25 is correct. X value 0, how many cases? Here x value 0, here x value 0, here x value 0. So x value 0, 3 cases favorable out of 4 cases. So x is minimum of 0 comma 1, minimum of 0 0, minimum of 0 1, minimum of 1 0 0. So minimum of 0 and 1, 3 cases favorable. In these two minimum 0, in these two minimum 0, in these two minimum 0, 3 cases favorable. Minimum of 1 comma 1, in these two minimum 0, in these two minimum 0, in these two minimum 0. Minimum of 1 comma 1 is 1. So minimum of m comma n, 1, only one case is favorable out of 4 cases. Do you know? Don't use any formula to find E of x. Don't use any formula to find E of x. Directly write in this manner. These two product plus these two product. This into this plus this into this. That is 0 into 3 by 4 plus 1 into 1 by 4. Answer 0.25. Answer 0.25. Just 2 minutes, I will give the break. Note this problem. If x and y you took minimum of m comma n as 0 comma 1. That is what I am saying. Look in the problem they mentioned, what first of all you are asking me why you took minimum of 0 comma 1 as 0 comma 1. You did not understand the problem. In the problem they mentioned simple question, please try to understand basics also. In the problem they mentioned two coin, one coin one side 0, other side 1, another coin one side 0, another side 1. So that type of coin is tossed 2 times. That type of coin was tossed 2 times. Possibility is first coin 0, second coin 0 will show. First 0, second 1 will show. First 1, second 0 will show. First 1, second 1 will show. In the problem, they gave x is equal to minimum of m comma n. Minimum of 0 comma 0, 0. Minimum of 0 comma 1, 0. Minimum of 1 comma 0, 0. Minimum of 1 comma 1, 1. So, possible values of minimum of m comma n are 0 and 1 only. For 0, 3 cases minimum. For 1, 1 case minimum. Possible 0 and 1 only. That's why I've taken 0 and 1. Write down. We'll continue after the break. Basics also you must understand. Simple questions you are also asking again and again. X is equal to 0 comma 1. It can be 0 0. X 0 0 na. What basic question you are asking again and again? Simple and silly question. Look here. Look there. Here x is equal to minimum of m comma n. Simple question. We'll continue after the break. Break was given 0 0 0 1 sorry 0 1 1 0 1 1. So x is equal to minimum of 0 comma 0 0. X is equal to minimum of 0 comma 1 0. Break was given minimum of 1 comma 0 0. X is equal to minimum of 1 comma 1 1. So therefore x values varying from, these are x values. So x values varying from 0 to 1. X values varying from 0 to 1. So x values varying from 0 to 1. Here x values varying from 0 to 1. For 0, 3 cases favorable out of 4 cases. For 1 case favorable out of 3 cases. Total 0 and 1 only. Total 0 and 1 only. For 0, 3 cases. For 1, 1 case. For 1 case. We'll continue after the break. $10 required. Break 10 minutes only. Yeah, who is asking the definition? Screenshot of variance. Okay, 1 minute. I hope you understand this. Those who asked the doubt. Another one. We'll continue after the break. So welcome back, students. So try this problem. A value 1 by 5, B value 2. No, A value 1 by 5, A value 0.2, B value 2. A value 0.2 and B value 2. Write down. Next, problem number 3. Suppose that one word is to be selected at random from this sentence. The girl put on her beautiful red hat. If capital X denotes the length of the word, the length of the word, that is selected at random then find one word is selected at random from the sentence, the girl put on her beautiful red hat. If capital X denotes the length of the word that is selected at random, then find E of X. E of X means expected length of the word. Variance of X means variance of length of the word. Listen to me, what are the words here? The words are words the girl put on her beautiful red hat. So, what is the length of this word? The length of the word 1, 2, 3, 3 words. Girl, length of the word 4 words. Put, length of the word 3. This is 2. This is 3. This is 4, 6, 9. This is 3. This is 3. So X represents the length of the word they mentioned. They have already defined the random variable. Random variable is already defined. (15/4) correct. Find variance also, Chatterjee. Now, length of the word. What are the lengths of the words? 3 units, 4 units, 3 units, 2 units, this. So, X values are 2, 3, 4, 9. X values 2, 3, 4 is also there, girl. Next to 5 not there, 6 not there, 7, 8 not there, 9. X means length of the word. Length of the words are 2 units, 3 units, 4 units, 9 units only. P of X. P of X means probability of 2 length of the word. Probability of 2 length of the word is only 1 was there. 1 was there. Total how many words? Total how many words? Look here. This is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8. So number of 2 length words only 1, that is on. Divided by total number of words are 8. Next, probability of 3 letter words. Probability of length of the word is 3. Length of the word is 3. Length of the word is 3. First one, third one, fifth one, seventh one, eighth one. 1, 2, 3, 4, 5. Probability of length of the word is 3, 5 units out of 8 units. Probability of length of the word is 4. We have only one 4 length word, that is girl, girl. So therefore, only 1 unit out of 8 units. Probability of length of the word is 9. That is beautiful. Only 1 is there. Only 1 is there. That is 1/9. So directly write E of X formula. I am going to the next slide. mean. Mean means these two product plus these two product plus these two product plus these two product. Don't use any formula. E of x means x into p of x plus x into p of x plus x into p of x on. E of x square means x square value into p of x plus x square into p of x, etc., etc. E of x is x into p of x 1 by 8 plus x into p of x 3 into 1 by 8 plus x into p of x 4 into 1 by 8 plus 9 into 1 by 8. Okay, fine. Nine into 1 by 8. This is 2 by 8 plus 3 by 8 plus 4 by 8 plus 9 by 8. This is 3 into 5 by 8. Let me check. Okay, fine. 3 into 5 by 8. So 2 into 1 by 8 plus 3 into 5 by 8 plus 4 into 1 by 8 plus 9 into 1 by 8. So this is 2 by 8 plus 15 by 8 plus 4 by 8 plus 9 by 8. This is equal to 17, 21, 30. 30 by 8. That is 2 15s, 2 4s. Similarly, before variance formula, E of x square minus E of x whole square. Before going to find variance, first you need to calculate E of x square. E of x square means x value whole square into probability, x value whole square into probability plus x value whole square into probability plus next x value whole square into probability plus next x value whole square into probability. So this is a 4 by 8, 9 5s are 45 by 8, 4 square 16 by 8. This is 81 by 8. 81 plus 6, 87, 87 plus 10, 97, 97, 102, 142, 146. 146. Therefore, variance V of x is equal to E of x square minus E of x whole square. 146 by 8 minus 15 by 8 whole square Simplify this and let me know the answer. Is it 73 by 14 or is it 67 by 16? 67 by 16. So 146 by 8 minus 225 by 64. Simplify and let me know the answer. 67 by 16 is the right answer. 67 by 16. Not correct, huh? 67 by 16. 225 by 16. Huh? Oh, if that is so, okay. 15 by 4. Okay, fine. Understood? Understood the mistake where it is done. 15 by 4 whole square. 225 by 16. Simplify this. Similar model problem was given in the gate. Try yourself. Problem number 4. 67 by 16. Good. Problem number 4. Similar model problem was given in the gate. Write down each of the nine votes. What happened? Once repeat third question. You said the answer and again you are asking why. This is third question. Each of the nine words in the sentence the quick, brown fox, the quick brown fox, gems, the quick brown fox jumps over the lazy dog. Is written. What happened, man? Continuously raising hands. The quick brown fox jumps over the lazy dog is written on a. Venkatesh Nidamanuri, if you have doubts, you can enter in question and answers. But you are not focusing on that. Volume question is written on a separate. Why you are unnecessarily raising hands, I don't know. I didn't go fast. Please don't raise hands. On a separate, then it impacts on my writing. On a separate, piece of paper, if you want you can use that formula. Separate piece of paper these nine pieces of paper are kept in a box. One of the pieces is drawn at random from the box. Full stop. Don't raise the hands. No meaning by raising the hands. If you can enter in question and answers, I'll check, and if it is genuine, I will answer. Still you have doubts, at the end of the session, we check. If you come late, then everything will be problem. The expected length of the word drawn is dash. It is a fill in the blank question given in the GATE Computer Science Engineering 2014. Try yourself it later. Answer 3.88. Fill in the blank question, you answer accordingly. Like that only you answer. Next, problem number 5. Note down. Passengers try repeatedly to get a seat reservation (35/9) is the right answer. Please write here. If I focus on that, it will be wasted time. Passengers try repeatedly to get a seat reservation in any train running between two stations until they are successful. Next slide. If there is 40% of chance of getting reservation in any attempt by a passenger. Then the average number of attempts need to make to get a seat reserved is a dash. This is the fill in the blank question given in the GATE Electronics Engineering 2017. Listen to me. Passengers continuously trying to book a seat for any train that is running between two stations until their seat booking is successful. They will try first time. Suppose seat not booked, they will try second time. Seat not booked, they will try third time. So passengers trying to book a seat again and again and again until it should be booked. There is a 40% chance of getting reservation. There is a 40% chance of getting reservation in any attempt by a passenger. There is 40% of chance of getting reservation in any attempt by a passenger. That means probability of seat booking successful is only 40%. What happened? Why you are continuously raising hands? I don't know. Please enter in question and answers. Don't raise hands. Here nothing is there. Don't raise hands means you are raising. I will check only at the end of the class. You can raise. I will talk. But in the middle, the class will not go smooth. Concentrate on what I'm teaching. Otherwise, the class will not go smooth and it is not good for you, for me, for everybody. Unnecessarily raising the hand, not suggestible for smooth going on class. So follow me step by step. There is a 40% chance of getting reservation in any attempt by a passenger. That means probability of seat booking successful is only 40%. Please remember that. So whatever you are asked to find, based on that you need to define the random variable. You are asked to find average number of attempts required. You are asked to find average number of attempts needed for seat booking is successful. Average means E, expected value. Number of attempts required, let it be X. Whatever you are asked to find, assume it as X. You are asked to find average number of attempts required for seat booking successful. Average means E. Number of attempts required, let it be X. Whatever you are asked to find, let it be X. Average number of attempts required. So X is equal to number of attempts needed. Answer is 2.5. Very good. Nerali Maheshwari. Answer correct. Now observe. Everyone follow me step by step. X means what? Number of attempts required to book a seat. Number of attempts required to book a seat. Do you know in which first time that person will try to book a seat? There is no guarantee that seat can be booked in the first trial. And we don't know in which attempt seat can be booked, no guarantee. So seat booking successful. Actually, passenger using his mobile to book a train ticket running between two stations. First time he will try. There is no guarantee that first attempt is successful, because server may be down or his mobile data may not be working properly. Second time he will try again to book a seat. He will try again and again and again until seat booking is successful. But in the statement of the problem, they did not mention in which attempt seat booking is successful. So therefore seat booking successful may be in the first attempt. In which attempt seat booking successful, no guarantee. So I am saying that seat booking successful in the first attempt, or seat booking successful maybe in the third attempt, or seat booking successful maybe in the fourth attempt or fifth attempt or sixth attempt. In any attempt we can book a seat. but there is no guarantee that in which attempt seat can definitely be booked. So that's why if no guarantee is there, then it will go up to infinity. Reason, in which attempt seat booking successful, no guarantee. It may be first attempt, or it may be second attempt, or it may be third attempt, or fourth attempt, etc. etc. So X means probability of seat booking successful in the first attempt. So that is 40%. Probability of seat booking successful is 40%. Means 40 by 100. Means 4 by 10. Means 2 by 5. Second is probability of seat booking successful in seat booking successful in 2 attempts. P of 2 means probability of seat booking successful in 2 attempts. Why you are taking 2 attempts to book a seat? Probably your first attempt was failed. That's why you are trying second time to book a seat. First attempt successful 2 by 5. First attempt failed 3 by 5. Second attempt successful 2 by 5. So probability of seat booking successful in 3 attempts. P of 3 means probability of seat booking successful in 3 attempts. Why you are taking 3 attempts? Because your first 2 attempts are failed. First attempt successful 2 by 5. First attempt failed 3 by 5. Second attempt also failed 3 by 5. So 3 by 5 into 3 by 5, 3 by 5 whole square. And third attempt successful, that is 2 by 5. So in which attempt seat can be booked exactly, there is no guarantee. So it will go up to infinity. Because seat booking successful in the first attempt or second attempt or third attempt or in which attempt it is successful, no guarantee. That's why. Now E means expected. X means number of attempts required. Expected number of attempts required means average number of attempts required. Its value, these two product, that is 1 into 2 by 5 or 1 into 2 by 5 plus 2 into 3 by 5 into 2 by 5 plus 3 into 3 by 5 whole square into 2 by 5, 3 into 3 by 5 whole square into 2 by 5, so on. 2 by 5 is the common factor, take it out. 2 by 5 into 1 plus 2 into 3 by 5 plus 3 into 3 by 5 whole square, so on. So the formula should be 1 minus x whole power minus 2. Same thing you are asking again and again. You are asked to find average number of attempts needed, average number of attempts required to get seat reserved. You are asked to find average number of attempts required. Whatever you are asked to find, let it be x. Average number of attempts required. Average means E, expected value. Number of attempts required, let it be x, E of x. Average number of attempts required. 1 minus x whole power minus 2, formula 1 plus 2x plus 3x square plus 4x cube plus 5x power 4, so on. So this is equal to 2 by 5 into 1 plus 2x plus 3x square plus 1, that is 1 minus x. Concentrating on writing, not on typing the questions. How 2 by 5 at x is equal to 1? Again, you are asking the same thing. Whatever I have explained, you are asking again and again, same story. X means what? Number of attempts required. X is equal to 1 means what? Probability of seat booking successful in the first attempt. Probability of seat booking successful is 40%. 40% means 40 by 100 here. Probability of seat booking successful in what one attempt is 40%, means this 40 by 100, that is 2 by 5. This is, if you can follow me step by step, doubts you will never get. This is 1 minus 3 by 5, that is 2 by 5 whole power minus 2, that is 2 by 5 whole power minus 1, and that is 5 by 2, that is 2.5. Next. Problem number 6. The random variable capital X has probability density function f of x is equal to ax plus bx square, 0 less than x less than 1, 0, otherwise if a of x is equal to 0.6, then find problem number 1, A and B, problem number 2, mean, problem number 3, variance. So you observe here, interval given, random variable continuous. Interval not given, random variable discrete. In this problem, interval given 0 less than x less than 1. So random variable is continuous. So to find the values of A and B for always regarding continuous random variable, you need to use sum of the probabilities is equal to 1. Sum of the probabilities is equal to 1. For a discrete random variable, sum of the probabilities is equal to 1 means sigma p of x is equal to 1. For continuous random variable, sum of the probabilities is equal to 1 means integral minus infinity to plus infinity f of x dx is equal to 1. So, but the problem is defined only from 0 to 1. Actually, minus infinity to infinity, problem is defined only from 0 to 1. Outside of 0 to 1, f of x is 0. So minus infinity to plus infinity will now be 0 to 1, will now be 0 to 1, and f of x dx, f of x is ax plus bx square.
Dear students, wait for 5 minutes. Dear student, wait for 5 minutes. Due to power problem, wait for 5 minutes. Dear students, wait for 5 more minutes. Dear students, wait for five more minutes. Session may start at 12:35. Session may start at 12:35. Dear students, sorry for the inconvenience due to power problem. So class has been cancelled. Dear students, sorry for the inconvenience. Class has been end for today. Sorry for the inconvenience. Tomorrow, as usual, the same time, 9 to 1. Dear students, due to power problem, class has been cancelled. Thank you. Sorry for the inconvenience.